Okay, so for any rule, if you like, to be a continuous random variable to be a probability density function, we need the integral of our rule. So let's just take 1 over x squared out the front. X is greater than a, so that means it's got to be from a to infinity. Now that needs to equal 1. Okay, so if I integrate that, that's the integral from a to infinity, a at the front of x to the minus 2 dx, which is equal to now a times the limit as some k approaches infinity of -1 on x between k and a. If I substitute those values in, I get that. I get the limit as k approaches infinity of -1 on k minus 1 on a. And as k approaches infinity, 1 on k approaches 0. So I get a times I get, that's a negative there, isn't it? So minus a minus, I get a times 1 on a, which is equal to 1. So it's a probability density function. The probability that x is greater than 2a, I probably need a little bit more landscape here. So for part B, the probability that x is greater than 2a is equal to the integral from greater than 2a, so from 2a, might even be easier really to do a 1 minus in some respects, and so we don't have to worry about limits. So what if I just go, let's rub that out. So it's really from 2a to infinity. So what happens if instead I do from a to 2a of 1 on x squared dx, which is equal to the integral of -1 on x. I've got an a at the front, of course. There should be an a on x squared between 2a and a. So that's equal to a times, what are we going to get there? -1 on 2a minus 1 on a, which is equal to a outside of. It's a plus in there. So if I we'll have -1 plus 2 over 2a. What's that? Which is equal to 1 on 2a times a, which is equal to a half. So my answer is 1 minus a half, which is equal to a half anyway. Okay, so we could have done a limit thing. It's not too crucial, I guess. And the next part of it then is I need to solve the integral. So I'm running out of room. The median value is I need to find the value of, say, k. I'll take a at the front, 1 over x squared dx equals a half. So the math is very similar. A times in bracket, we're going to end up with -1 on x evaluated between k and a. That is equal to a half. Let's evaluate that first. I get a times -1 on k, minus a minus is plus 1 on a. That has to equal a half. So I have to solve that for k. So what's the easiest way to do that? If we multiply our a in, we're going to get negative a on k plus a on a, which is 1, equals a half. So subtract, so I'm going to get a half is equal to a on k. So k will equal 2a. All right, so it's a little bit messy with the amount of algebra in there. But yeah, see, work as best you can. Let's make this bigger again. Probability density function, continuous random variables are given by that, between 1 and 5. Find the probability that x is less than 3. So straight away, I know if x has got to be less, if x has got to be, let's just undo that. If x has got to be less than 3, that means it's got to go from 1 to 3, x on 12 dx. Okay, so add 1 to the power is x squared on 2, so it becomes x squared on 24 evaluated between 3 and 1, which is equal to 9 on 24 minus 1 on 24, which is 8 on 24, which is equal to 1/3. Find the probability that x is greater than a is equal to 5. If the probability of x greater than a is equal to 5/8, find the value of a. So x has got to be greater than a, so it's got to be greater than a, but can't be any more than 5. I'm going to take that 1/12 out the front to make the math a bit simpler. dx, and that has to equal 5/8. So integrate, I've got x squared on 2 between 5 and a is equal to, if I multiply the 12 across, that becomes 60 on 8, which is 30 on 4, which is 15 on 2. So the left-hand side becomes 25 on 2 minus a squared on 2 equals 15 on 2. So we add and subtract. That will give me, take a squared on 2 onto the right-hand side, 15 on 2 back, equals 10 on 2. So a squared will equal 10. So a equals plus or minus the square root of 10. Since a has got to be between 1 and 5, a is equal to the square root of 10. Okay, so again, we've got a function that we need to show or prove that it's a continuous random variable, which means the integral. So for part A, it means that the integral between 0 and 1, I'll take k out the front, of sine pi x dx has to equal 1. All right, so k out the front, antiderivative of sine is negative cos k, so negative 1 on pi, cos pi x, evaluated between 1 and 0, has to equal 1. So then k times negative 1 on pi, cos pi minus negative 1 on pi cos 0 is equal to 1. So k outside of, well, cos of pi is negative 1. So negative 1 on pi times negative 1 is 1 on pi, minus cos of pi is equal to, minus cos of 0 is also 1. I can't be right. So let's have a look. So it should be negative 1. So it's a minus minus there, isn't it? So it should be a plus equals 1. So I get 2 on pi k is equal to 1. Therefore, 2k equals pi, k equals pi on 2. Good. So now find the probability. So a conditional. So again, first step of conditional, probability that x is less than 1/4 and x is less than 1/2 over probability x is less than 1/2. So what values are less than 1/4 and less than 1/2? So that's just the probability that x is less than 1/4 over probability that x is less than 1/2. We worked any of those out? We haven't. So let's do probability that x is less than 1/4 is equal to the integral. We'll give a k value at the front, which is pi on 2. Pi on 2 out the front of less than 1/4. So it's 1/4. 0 to 1/4 of sine pi x dx, which which is equal to pi on 2, antiderivative of sine, pi x is negative 1 on pi cos pi x, evaluated between 1/4 and 0, which is equal to pi on 2 outside of. So put 1/4 in there, you get cos pi on 4, which is root 2 on 2. So I get negative 1 on pi times root 2 on 2, minus a minus, which is plus. Put a 0 in there, I get cos of 0, which is 1. So I'm going to get minus 1 on pi, which is 1 on pi. So what if we just leave that as that line there? Now let's have a look at x is less than or equal to half is pi on 2 at the front of a half to 0 of sine pi x dx, which is equal to pi on 2 at the front of negative 1 on pi cos pi x between a half and 0 equals pi on 2 outside of. So cos of pi on 2 is 0. So I get 0 minus cos of 0 is 1 minus 1 on pi. So that's just equal to, what's that? That's pi on 2 times 1 on pi, which is equal to a half. So therefore, my probability is equal to, well, the bottom line came to a half. The top line comes to pi on 2 outside of what's that? Negative root 2 on 2 pi plus 1 on pi. So pi will go into there and there. So the top line becomes, multiply a half in, negative root 2 on 4 plus a half all over 2, or over a half, I should say. So to divide by a half, turn it upside down and multiply by 2, I get negative root 2 on 2 plus 1. Righto. We've got a random variable x distributed probability function where A, find the value of A. Geez, we've done this a few times, haven't we? So let's start with, so if I take A out the front as a common factor, I'm going to multiply the x in. I get 5x minus x squared dx between 0 and 5, and that has to equal 1. Okay, so I get A, add 1 to the power, so 5x squared on 2 minus x to the 3 on 3 between 5 and 0 has to equal 1. So A outside of, substitute 5, so 5 squared times 5 is 125 on 2 minus 5 cubed, which is 125 on 3, minus, put 0 in, which is 0, is equal to 1. So I get A times, if we make them both on 6, what are 3 125? 375 minus 2 125 is a 250. That's equal 1. So I get, what's that? I get A times 125 on 6 is equal to 1. Therefore, A is equal to 6 over 125. What's the last one? Express the probability that x is less than 3 as a definite integral. So the probability that x is less than 3, so 3 to 0 of A, so we'll just write it as 6x on 125 times 5 minus x dx, do not evaluate. So that's all we need. Too easy. Question 5. Continuous random variable x has probability of function. Find the exact value of a. So that probability of x is less than a is equal to a quarter. So that means we need, so the, probability that x is less than a is equal to, from a to lower bound 0, 4x cubed dx has to equal a quarter. So integrate, I get add 1 to the power and divide, so I get x to the 4 between a and 0 has to equal a quarter. So a to the 4 is equal to 1 quarter, therefore a is equal to the 4th root of a quarter, which is equal to, what is that equal to? A is equal to 1 over the 4th root of a squared. So it's going to be equal to 1 over root a, isn't it? No, I'm not too sure about that symbol, but I'm assuming that's just some less than or equal to's or less than. It's not going to matter for a continuous distribution. So we need the probability that x is between 1/2 and 3/4 of 4x cubed dx. So really it just becomes an integration question. So let's take 4 out the front. Actually, I won't do that, sorry, because I add 1 to the power, divide by the power, I just get x to the 4. Oops, let's scrub all that out. Scrub all that out. So we're just going to end up with the integral of, x to the 4 evaluated between 3/4 and 1/2, which is equal to 3/4 to the 4 minus 1/2 to the 4, equal to, so 3 squared is 9, 9 squared is 81 on 4 to the 4, 64 times 4 is 256, minus 1 over 2 squared is 4, 1/16. So that's the same as 81 on 256 minus 16 over 256, which is going to give me 75/65 on 256. All right, so just notice I keep everything in a fraction if I can. All right, because 0.5 to the 4 is easier than a half to the 4 is easier than 0.5 to the 4. Last page. Probability function, blah, 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 show that k. So again, integral between 1 and 3, let's take k out the front. I'm going to expand that bracket, x squared minus 8x plus 16. I guess we didn't have to, we can use the, maybe I'll do that. Use that little expansion rule for a linear expression. Integral of x minus 4 squared dx is equal to k at the front. So we add 1 to the power and divide by the power over 3, and then also divide by the derivative of x, which is 1, and evaluate that between 3 and 1, which gives me k outside of, pop a 3 in there, 3 minus 4 is -1, -1 cubed is -1, over 3 minus, put a 1 in there, 1 minus 4 is -3, -3 cubed is -27, over 3. That's has to all equal 1, obviously, for it to be a probability density function. So I get k equals -1/3 minus a minus is plus. So -1 plus 27 is 26 on 3 equals 1. Therefore, k is equal to 3 on 26, which is what we were looking for. Notice how I don't take any shortcuts. I work out every step. Okay, certainly can't get to a step like that and go, oh, look, k equals 3 on 26. Probability that x is less than 2. Let's take the k at the front, which we said was 3 on 26. So probability that x is less than 2 is equal to 3 on 26 outside of the integral between less than 2, so it's between 1 and 2 of x minus 4 squared dx. So again, 3 on 26 outside of, we've got that antiderivative from earlier, over 3 between 2 and 1, which is equal to 3 on 26 outside of everything. Put a 2 in there. 2 minus 4 is negative 2. Negative 2 cubed is 8, or negative 8. Negative 8 on 3 minus, put a 1 in there. 1 minus 4 is negative 3. Negative 3 cubed is negative 27 on 3. So we get negative 8 plus 27. So we get 3 on 26 times, what did I say? Negative 8 plus 27 is 19 on 3. 3's cancel. 19 on 26. Last one, I think. Last one. Probability density function conditional variable blur. Show that A. Boys, do you see how important a skill it is? So once again, I need to show that the integral from ax plus 1 of ax plus 1 dx between 1 and 3 has to equal 1. So I get ax to the 2 on 2 plus x between 3 and 1 has to equal 1. So I get, substitute 3 in there, I get a squared 9, so I get 9a on 2 plus 3, subtract a on 2 plus 1, which gives me 9a on 2 minus a on 2 plus 3 minus 1. So I get 8 on 2, which is 4a plus 2 has to equal 1. So 4a equals negative 1, a equals minus a quarter. Job done. Limits 1 and 2. Negative a quarter x plus 1. Correction, job not done. I didn't see the last page. So probability that x is less than 2. So it's less than 2 is the integral between 1 and 2. A was negative a quarter, I think. So negative quarter x plus 1 dx. Let's just check that. Between 1 and 2. So that's equal to, add 1 to the power and divide, negative x on 8 plus x between 2 and 1, which is equal to negative 2 on 8 plus 2 minus negative 1 on 8 plus 1. So negative on 2 on 8 plus, minus on minus is plus, so I end up with minus 1 on 8. 2 minus 1 is 1. So I get 7 on 8. Righto. Continuous round of variation probability is given by, find the probability that x is less than 2. So again, less than 2, so it's been 2 and 1. Does it matter? Take a half out the front. I'll write that as x to the minus a half dx, which is a half outside. I've add 1 to the power, which is 1. So negative a half plus 1 is x to the half over a half between 2 and 1. So now my halves actually cancel. So I get x to the half evaluated between 2 and 1, which is 2 to the half minus 1 to the half, which is root 2 minus 1. Find the mean value of x. So the mean is when the whole thing equals that's the median, isn't it? Jeez, Mr. Carl. So mean is the expected value, e of x. I haven't done one of these for a little while. And that's equal to the integral between 1 and 4 of a half times 1 on root x, but remember, x times that, yeah? So that's equal to a half at the front of 1 and 4. X times root x is x times x to the negative a half, which is x to the half, which is equal to 2 outside of, add 1 to the power, 3 on 2. So it becomes 2x to the 3 on 2 on 3, evaluated between 4 and 1, which is equal to 2 times. So if you like, we're going to go, well, we could take the 2/3 out, couldn't we? 2/3 times 2, and x to the 3 on 2 is 4 to the 3 on 2 minus 1 to the 3 on 2. So I get 4 on 3 out the front. Now, x to the 3 on 2, if I just break it down, that's the same as 4 to the half cubed minus 1. Well, it doesn't matter really how I write the last one. The only reason I'm going to do that is because 4 to the power of a half is the square root of 4, and the square root of 4 is 2. So I get my 4/3, and I really end up with 2 cubed minus 1. 8 minus 1 is 7, so I get 28 on 3. Now we're done. Good luck.